DJing or if I'm able to make it down there. I've been on a team for dodgeball once, but I mean, I'm down to play dodgeball. The problem is, I don't know if you guys are ready for me.
I am so
But
ready.
if I'm able to slip away from my DJ Hubcap role, I will put on a dodgeball.
Did you say that was like your job in like college?
Well, it was I didn't really get paid for it. The DJing the radio was more like a volunteer type gig just because we wanted to. I had a couple friends who were actually like communication majors that they had to do that like for their classes, but I just did it because I wanted to.
Yeah.
I enjoy music and everything. So we.
Nice dad.
Yeah, thanks. We are going to finish your masteries tomorrow, as well as watching the documentary or a section of it. Today I wanted to just introduce us to a new concept that uses powers. But we'll probably make it through this in, I don't know, I'm guessing we'll make it through this with some time to spare. So then we can talk about what documentary we want to start. We might start it today. No, the math documentary.
We should just watch a bunch of number 5.
I mean, number file is sweet.
I
So,
love it.
that is an option.
No, he's
Yeah, God.
It's a sign.
Oh,
And then like.
hey, let's watch the movie.
This needs to go home with you. Get that sign and bring it back. Because then, so you can just take that straight to the office tomorrow, and then they'll give you a sign stuff, and you can take it home, and it's got a Verizon card in it.
Okay.
So, we looked at this table, except in a different way.
How do we look at it?
If you go back to the negative exponents notes, you don't actually have to go back to them. But we looked at a table involving, and I forget what our base number was, but let's say we had 3 squared. Well, that's 3 times 3, or it comes out to be 9. 3 to the first was just 3. 3 to the 0 was 1. Then what about 3 to the negative 1? Sorry, you can't really see my negative there. What did the negative exponent do? Because it didn't make my value negative, and that's what most people think. Andrew? Ignore that table for the current time. We're just reviewing what negative exponents tell me. Jeremiah? Makes it 1 over 3 to that power. So if it's 3 to the negative 2, that's 1 over 3 to the second power. So, where scientific uses those powers, your power is always on 10. Because when you get into scientific application, I guess I might as well capture this, you have to represent really big numbers and really numbers. Like the size of an atom. So, when we have really big numbers or really small numbers, we don't want to write the whole thing out because we're efficient. Not lazy. We're efficient. So, instead of writing out 5,000, now that's not a really big number, but it's a bigger number, I could instead write it as 5 times 10. Now, obviously, it's not just 5 times 10. But I can multiply by as many 10s as I need by just using a power. So if I need to do 5 times 10 times 10 times 10 to get to 5,000, I could instead just say 5 times 10 to the third. So please, off to the side here, notate that this actually means 5 times 10 times 10 times 10, which that is 1,000. And that is how we get 5,000. Likewise, this down at the bottom is 5 times 1 over 10 times 1 over 10 times 1 over 10. Or we could have just written it as 5 times 1 over 10 to the third, which is 5 times 1 over 1,000, which comes out to be 5 thousandths, or 0.005. And there's an even easier trick for this. That exponent on that 10 is actually telling you what to do. And by what to do, it's telling you a shift, a move that happens to your decimal point. Can anyone figure out what I mean? Bless you. So like my 5,000 here says 5 times 10 to the third. So right now my decimal point is right there. Dom?
Okay, so for the decimal point, for the negatives, when it's -1, the decimal point moves 1 place over to the left. And then for -2, it moves 2 decimal places over to the left. And then for -3, it goes 3 places over to the left.
So what is the positive 3 telling me to do with my decimal?
Move the decimal point 3 places over to your right.
So this, being positive, tells me to move my decimal right because that will make my value larger. So I move once, twice, 3 times. And since there were no numbers there, what numbers are actually there? Zeros. And that gives me 5,000 as the actual value there. So we had 5 times 10 to the 17th. That would just tell me move your decimal 17 times to the right. If we had 5 times 10 to the -8th, we'd just move it to the left 8 places. Be careful with the negatives. The most common issue that I see with exponents is when working with the negative, like take 5,000ths, for example. This we represent as 5 times 10 to the -3rd. Some people will have issues realizing that this is a spot. That's a move. So there are only 2 more to move, which is how we get 0 point, only 2 zeros in front of it, because the 5 itself took up one of those shifts. Questions on that? That's just the if I think back to previous years, that's something that I feel like I needed to cover in more depth. So, check this out. Answer these questions, true or false. Try it on your own. You can use the table to reference. By the way, Manasa, good luck. Hopefully you did well today. She said she's gonna watch this like as soon as she gets done with the competition. We'll see if she actually does. You're gonna run a test. Let's run a test. Hey Manasa, if you're watching this video, email me right now. Just email me and say I saw it. I'm curious if you do it. No, but she asked me to upload it like as soon as we get done with class, so that it would be up there by like noon when she gets done with her robotic stuff. So Julian, when we look at number A here, as the power or as the exponent of 10 increases, the number becomes greater. That is true because the exponent of 10 is telling me what to do with my decimal. Move it to the right or move it to the left. Ellie, what about a negative exponent of 10 makes the number negative?
False.
Ooh, what does it do to the number?
It just puts the number under 1.
It makes it smaller, right? So a negative exponent would make our value smaller. Mr. Hone, what about 5 times 10 to the third is greater than 5 times 10 to the third?
That is true.
That is true. Higher power means larger value. And Sean, what about 5 times 10 to the -3rd is greater than 5 times 10 to the -3? Or the -2?
That's false.
False, because the more negative your exponent is, the smaller the number gets. It does not go negative, it just goes smaller.
It's so quiet without Monster.
That's kind of mean, but you're not.
No,
You're
I'm
not
not trying to be
wrong.
mean. I'm just saying, like, it's really quiet now.
Well, so one thing is she's great at asking the questions that a lot of us are kind of thinking, but we don't have the confidence to ask it. She just asks it, which is great. Some teachers get like, whatever about it. I'm perfectly fine with it. she does a good job at like placing where your question goes. So with her not here, you guys got to step up and ask those questions that she would normally ask. So if something's confusing, please ask me, because we don't have Monica here to ask those questions when I don't explain things well enough. Try this. Order these from least to greatest. Be careful. They all start with a 2.34. So Lena, if we look at that list and we're looking for the smallest value up there, which would be the smallest value?
I don't know yet.
Perfectly fine. If we look at 3 here, it isn't in scientific notation right now. Because to be in scientific notation, and we'll talk about this in the key concept, it's got to have a times 10 to the. Now, if it doesn't have a times 10 to the, we can give it 1.
Wait, what? 1. 0.
So wait, what are you telling me? What is? But if I make the exponent 1, that will make this times 10. 2.34 will change what it is if I multiply it by 10. That would change this number.
Oh, 10 to the.
Ooh, 10 to the 0. I'm going to rewrite that because those look like the same size numbers. But if we make this times 10 to the 0, what's a number to the 0 power?
Uno.
1. What does multiplication by 1 do?
It's the
Nothing.
same.
Stays the same. It's the identity. So then we can say our lowest value will be, do you know it? Yeah, the second one. The more negative your power is, the less the value will be, the closer to 0. So my lowest value here will be 2.34 times 10 to the negative 2. Then my next value here, as I work higher, Jeremiah.
Triplets.
Huh?
3.
You're
Or not
funny.
3. Not 3.
Number 3.
2. Just
It's 3.
2.
So we just used number 2 for the lowest
Oh,
value.
yeah.
So that was my lowest because this would actually be 0.0234. Now, don't say triple because that is mathematically incorrect. So then we use option 3, which if you want to write it is times 10 to the 0. And then my next, well, we only have one left over. So
I think I have the answer to all of those.
You did the math.
you don't need the, like, that's just the scientific way to notate it. We could represent it in decimal form, not in scientific notation. We don't need to. We just needed to order least to greatest. The most important aspect of scientific notation. The reason that we use it, and it works. This first number has to be between 0 and 10. It cannot be 0 and it cannot be 10. It must fall between them.
Why not?
So this value, if you want to notate it here, if we call this, I don't know, A. So A falls between 0 and 10. We must use times 10 because that shifts decimal. And then the power tells me how far and what direction.
Why can't it not be over time?
Because then it's not a standard form. So when we work in scientific notation, we do this to compare values. If I gave you 2.34 times 10 to the second, and then I gave you 234 times 10 to the negative 2, this doesn't really make sense because they're both using a times 10, but this value starts with a small number and it tells it to get bigger. This value starts with a bigger number and tells it to get smaller. So we created, mathematicians created a standard rule that if we start with a value, and we're going to use a power of 10,
You can still get anything, and if you were just up higher than
change the numbers.
So this, in reality, would move my decimal over and put it here. So this would then just become 2.34 with no power of 10, with nothing going on. This could become 234 in actual decimal form, but these are not the same. They'd be very hard to compare because they start with values that aren't the same. So another reason that we use this is imagine that we have 2 times 10 to the power that are the same. So let's say we have times 10 to the 4th and times 10 to the 4th, and you're trying to compare which number is bigger. Well, if this number starts with 3.82 and this number starts with 4.15, which one's bigger? The 4.15 value, because if they both have the same thing happening to their decimal, we just compare the first values. So that's why we have to have only one digit to the left of the decimal. And really the main reason we do that is so we have one digit decimal point, and then if we need more digits, we can put them after the decimal point, but that depends on how specific I want to be. This also lets us approximate things. So if I look up, let's say we look up the size of a mole. Not a mole on your face, but like a mole, scientific mole.
Right.
Size of a mole. Let's see if they have any scientific notation here. They should. Yeah, it's the same thing. I'm just saying I'm trying to find something given in scientific notation. So, like this. 4,7,500,000 centimeters. Compared to, I don't know, probably an atom, something like that. 0.000000001. If I want to be able to compare these in a standard form, I would make this 4.0075 times 10 to whatever power I would need to get it back to normal. But this I could represent just as 1 times 10 to whatever power I need to get that to shift the decimal back to where it's going.
That's what
It will be a negative power though, because it's a very small number. So we don't go too deep into this today. We go a lot deeper tomorrow. Or not tomorrow, but the next lesson is dealing. I don't need to calculus, I already did. Dealing with super big numbers, and then the lesson after that is super small numbers. This is just making sure you understand the basics. So for us to not take too long with this, yeah, Ozzy.
That was I did the calculation for that. Was that how many atoms take up the world?
Yeah, I think that's probably what they were going
That's
to compare.
4.0075 times 10 to the 17th.
Yeah, 17 shifts to your decimal that would have to happen to get it into its decimal form.
Which is a lot.
I bet you only need 15 seconds to identify which of these are accurately in scientific notation and which ones aren't. Circle the ones that are in scientific notation. So it's got to have a number to start with that is between 0 and 10. Really, sorry, it's between 1 and 10. I said that wrong on the last side. I need to
Oh,
correct
between
that.
1 and 10?
Yeah, my bad. I meant to say 1. I don't know why I thought 0.
Circle the ones that do work or that don't work.
So this right here, sorry, I goofed it on the last slide and in my smart book. This should be between 1. So when I said this right. There should be a digit to the left of the decimal. That's it. All you got to remember is a digit to the left of the decimal. Not more than 1, not less than 1. A digit to the left of the decimal. Richard Marcel is like yelling at the computer. Mr. Hudson, you're saying it wrong. Well, and it's written there in your notes, in that little box. I have it in there for you. I just said it wrong because it's early. I make mistakes occasionally.
And also it's almost spring break. And even teachers relax.
And also spring break.
And I was at a track meet last night until 7:15, and then I came home and was in a meeting on Google Hangouts until 8:30, and then I finally got to eat dinner at 8:30
Why'd you
So-
just
It was
do
so
Google
small.
Hangouts?
because we don't want to drive to Westerville to have our meeting, so we just all do it on Google Hangouts.
That's cool.
Let's bust through these. We're gonna go left to right telling me whether it is or is not scientific notation. So Jaslyn, my first one here, is this scientific notation? No, because that first number is larger than 10. Andrew, my next one. Ooh.
Wait, no, it's not 10.
This would need to be a base of 10. It's not scientific notation. Anish, what about this one? Yeah, so that one's kind of like, The first number is between 1 and 10, but it doesn't have a times 10 to the. This is not scientific notation because it doesn't need to be. We could make it scientific notation and say times 10 to the 0, but that's dumb. We don't need to do that. So this is kind of that weird in between. It doesn't need to be scientific notation. It could be, it doesn't need to be.
So that means scientific notation.
As it was written, no, but if we write it like this, it is.
But it's
So, like, it's dumb. Like, we don't need to do that. Whitney, what about my next one? It is scientific notation. It's kind of dumb. We don't need to do that. But just like we did right here, if it's times 10 to a power, if this first number is between 1 and 10, Dom, my next one.
Okay, so I said that wasn't scientific.
You say was or wasn't?
Words and that, right?
This one, yeah.
Oh, yeah, okay. So I said that it wasn't. Or it, what?
What do you think?
I say it's not in scientific notation.
Why not?
Well, because the negative makes, you have to move the decimal places 3 places over, so it'd be 0.010.
No. So this tells you to move your decimal over 3 places. It's moving this decimal over 3
I was
places.
looking, okay.
So that would become 0.004. But is this, we're not even worried about what the number turns into. Is that in scientific notation form? Is this number between 1 and 10?
Yeah.
Is this times 10 to a power?
Yeah.
We're in scientific notation.
Woo.
Samantha, what about the next one?
yes.
Yeah, and you do not want to write that number out. That would shift your decimal 120 places.
That'd be
That's an
really
insanely large number. Monica, your card got pulled. Ozzy, next one.
I said yes.
It-
No.
Is this between 1 and 10?
Is it 10 or less?
It
Oh.
can only have one digit to the left of the decimal. If I put my decimal point here, it's got 2 digits to the left. It is not.
Oh,
Yeah.
that's surprising.
It's got to be between.
So from 1 to 9.
Well,
It's one
1
through nine.
point anything.
Okay.
So like 1.00001 is still bigger than 1, and up to 10, but not including 10.
But
Okay.
So the biggest thing is you have a single digit here, decimal point. Whatever's out here doesn't matter. There can be multiple digits or no digits. Times 10 to a power. That's all that matters. 1 digit decimal times 10 to a power. Ozzy?
But can't it still be 1 though? Because on the key concept it says less than or greater than or equal to 1.
Yeah, it can be 1, but we say you're trying to express a billion. You could express a billion by saying 1 times 10 to whatever power it needs. This we can rewrite in scientific notation. This would actually be 1 times 10 to the 7th instead of 10 times 10 to the 6th. We move this decimal over and tell our power, hey, you actually got to go 1 more place. We can use the 1, we can't use the 10.
Okay, yeah.
But the biggest thing is 1 digit before your decimal. So if there's a 0, that doesn't count. That's not a digit. This gets into significant digits, which we haven't really talked much about. We'll get into it after spring break. But significant digits are digits that matter. A 0 out here does not matter. A 0 right here does matter. This is significant. This is not. So that's the whole 1 digit, whether or not that digit matters. If I do 0.67 times 10 to the 3rd, this 0 is not a digit. It is not doing anything. It does not count. This is not scientific notation. Noah, what about this last one? Yeah, sorry, I just kind of gave that away. I didn't realize that we were about to do one just like that. Questions? Wanted to make sure we were clear. You gotta have that digit out in the front. Mr. Smith. Last card on the bottom here. And the got it. Is number 1 in scientific notation?
Yep.
Is number 2?
Nope.
Why?
Because it's way higher than 10.
Yeah, we've got 2 digits to the left of that decimal. What about number 3?
Yep.
Yeah, so we have yes it is, no it is not, and yes it is. Suppose we multiply 2 gigantic numbers, 800,000 by 7 million. And we get 5.6 trillion, had to count how many sets were there. We don't really want to express 5.6 trillion every time we write it down. That's a lot of zeros and a lot of wasted time. So instead, we become more efficient and we use scientific notation. So this we could represent as 5.6 times 10 to the, well guys, let's look at how we make scientific notation. If I now have my decimal here in the 5.6 that I wrote, how far does it need to move to get to where it actually belongs? Sean? 12 spaces. So we do times 10 to the 12. Now this, and I hate this, is where things get really complicated. E has 2 different meanings mathematically. And I hate that they chose to do this. E is a number, and also it's not. E, so this is a problem. They use it 2 different ways. So it's like when I had 2 Jeremiahs, right?
And you don't say Smith or.
So that would be like if, and this is going to dance that fine line, but if somebody said Jeremiah's hair is curly and not, Jeremiah's got blonde hair and he doesn't, right? So there's 2 different Jeremiahs in 2 different, like they are 2 different things. E is used as Euler's number, or Euler, depending on who you ask and how they pronounce it, like Euro and Hero and Hyro and whatever. So
Hieroglyphics.
Euler, or Euler, Leonard Euler, was a famous mathematician. He wrote a bunch of different theories and formulas. E represents a value. It's like 1.6 or 1.7, it's around there, something like that. E right here is telling us to the exponent of. So please highlight that E is telling you exponent of 10 is positive 12. That's telling us exponent of 10 is positive 12. So sometimes, depending on the calculator that you're using, it'll come up with a times 10 to the power. It'll look like scientific notation. Sometimes it will come up looking like this. And you need to be able to identify that actually means this. 5.6 times 10 to the 12. Questions?
Why do they do that?
It's just calculator notation. And sometimes your calculator doesn't have enough space to put times 10 to the, so it'll just put E12. And it's a little bit shorter for it to write.
Wait, but our exponents are way smaller.
No, it depends on how your calculator plugs it in. If you're talking about size of the number on the screen,
Yeah.
sometimes it will just show the caret symbol and then just have the number full size. So it shows that caret symbol, which, by the way, I wanted to review this. Everyone grab a yellow calculator if you don't have one. I answered this question too many times yesterday. If you don't have one, put a yellow calculator in front of your face.
Oh, there's one in front of my face, but it's okay. Then I
Directly. Right on the left side of your calculator, where you have x squared. That is the square ring button. the secondary green button at the top left, secondary button will get you the second function, which most of us have become familiar with. Hit second, that x squared, it pops up with a square root symbol, and then you can square root whatever you want. Clear all that out. Those are the easy ones. If you want to do a power to a number that is not squaring, the button above it, the caret, the little like where you would edit text and say like, oh, you should actually have this word here. So that caret, everyone type in your calculator, 3 caret 24.
What, 3
Do you get 2.82?
It won't let me.
What do you mean yours won't let you?
It told me I have a syntax error.
Ah, go switch your mode.
Okay.
Whether it's in classic or math print, flip it. Yep.
And then, 3, that thing.
Notice at the end of this, you should have a result that comes out to be 2.82 times 10 to the 11.
Yeah.
That's your calculator saying, okay, hold on, man, calm it down. You have a number that's way too big for me. Your calculator is limited to how many numbers it can show you. This number would be off the calculator screen. So, to compensate for the fact that we didn't want to make calculators super big, and computers didn't exist, we created scientific notation to say, okay, there are other numbers out there. Right? There's, after that 2, there's really a 4, 2, 9, 5, 3, 6, 5, yada, yada, yada. But those numbers mean less, they're less important than the beginning numbers. So scientific notation is also used for your calculator to be able to represent super big or super small that it wouldn't normally be able to fit on the screen. So, in your calculator, type in 52 million times 100 million and see what you get. And especially when the numbers involve lots of zeros, then there aren't a bunch of digits after that. Sean, what'd you get?
5.2 times 10 to the 50. Verified. Verified.
You verified yourself. Nice.
6,000.
Now you could also write that as 5200000000000000000, I think. Then a decimal point. But that would be dumb. We'd rather represent it like that.
And not fun.
What about your second value here? 52 divided by 100 million. Evie?
5.2 times 10 to the negative 7.
Good morning. Angelina Hipsley, please come to the office. Angelina Hipsley to the office, please. Thank you.
Verified?
Verified.
Yay! Wait, to the negative 7? Oh, wait, yeah, that's
Yep,
what I got.
because it's getting smaller.
I know, that's what I got.
That division makes the value smaller. What about the next one? Moon, can you help me out? 52 divided by 100 billion.
Man.
I got 5.3 times 10 to the negative 10.
Negative 10. Anyone else verify it?
Verified.
Thank you. Ashley, what about the last one here? 520 billion times a trillion.
That's a trillion?
Well, no, sorry, billion.
Okay.
520 million times a billion. Sorry, I
There's
said
a
that.
trillion up here. It's like the sign of God. That's
Yeah, there.
5,
Yeah.
6.
Ashley, what'd you get here?
I got a 5.2 times 10 to 15.
10 to the 15th power. Now wait a minute, that's the same as the first one.
It's 17.
Yeah, I was about to say, I wonder if you typed it in. It's hard to get all the zeros in there correctly,
I got
so
5.
check that you have all the right number of zeros.
I got 17. Like, 10 to the 17.
So let's look at why. Compare your first to your last year.
Okay.
This 52 million compared to 520 million. This is 10 times bigger. So this has an extra times 10. 1 billion compared to 100 million. is another times 10 bigger, which is why instead of getting 15 times 10s,
17.
we get 17 times 10s. We have 2 extra times 10s happening.
You think you're gonna get a new smartboard by next year?
I don't know. Some days it works, some days it doesn't. It all depends on where I'm writing.
Yeah. Where
So, this in scientific notation. Lena, can you help me out? This would be, left the room. Samantha? 7.7, if I write this in scientific notation.
times 10 to the negative 11.
Times 10 to the negative 11. We also, here, a lot of times bring back the extra multiplication. Because you can write it with the dot. But because there's a decimal right here, and you're going to use another dot, like you can use the dot, but you may also bring back the extra multiplication. Any remaining questions on this stuff? That is everything for today.
Yay!